Hello and welcome to another episode of Math with Shinrai Sensei and our Better Together at Math series. Today we're going to go over some basics of geometry, but it'll also kind of cover something that you can use in science. The last two episodes have been kind of weird, huh? You've got scientific notation and now you've got stuff to do with science coming into math, right? Now, science and math have a very close relationship, but we'll go into dimensions real quick. Right? So dimensions are extremely important in both science and math. So most often you're going to see there's three dimensions that we can see and interact with in science. And there's a fourth dimension that we cannot see, but we do constantly interact with, whether we realize it or not, called the fourth dimension, also known as space-time. And obviously, as the name implies, space-time, there's a very deep correlation between space and time to the point that they may as well be one for the purposes of the fourth dimension. So, there's three dimensions that we interact with and that we can measure in any meaningful way. And they're on three axes, right? So you have an x-axis, which is this way. You have a y-axis. Let me go ahead and make that a little better. There we go. And then that goes up and down. And then the z-axis is hard to depict. Most often you'll see it shown as kind of like coming straight out from here at an almost 45-degree angle. And this is a z-axis. And while really it should be coming out in both directions here, hypothetically, when you're trying to draw three dimensions, it's really difficult on a two-dimensional surface such as this board. You have a difficult time showing on this graph anyway, X, Y, and Z. Now, it's easy to show on the graph when you're trying to draw three-dimensional objects, such as a cube, a prism, things like that, right? But it's hard to show when you're just drawing the axes, what three dimensions looks like. So most commonly and easily, it's easier to see when you take the form of a shape. So X, Y, and Z. Oh, take a screenshot of that last page. If you really need it for study, please take a screenshot. But the easiest way to show it is to draw a basic shape like a square or a rectangle, and then turn it into a prism, right? So, boom, boom, boom. Draw that out. Not the greatest freehand artist, if you guys couldn't tell, but there you go. This is the easiest way to show a three-dimensional object on a two-dimensional plane, such as this board, because you can't really show the axes without having a object on the axes to show that the z-axis isn't just a 45-degree angle coming off the x and the y. Three-dimensional objects are the only way to show that. So this would be a cube or a rectangular prism, depending on whether or not you think that it's a square. It doesn't really look like a square to me, so I'm going to call it a rectangular prism. But there are three dimensions, three axes, which are all represented by this is the x, this is the y, and let's call this one the z. So the x-axis goes this way, the y-axis goes this way, and the z-axis goes that way. It's the easiest way to think of it. I wish I had three arms to go ahead and show you guys this and actually hold them all in the correct position to show you guys, but unfortunately, I was born with only two arms. I'm a little too normal in that respect. So, I apologize for not having three arms. But I hope this shape will help you guys kind of get an understanding that the x-axis goes this way, y-axis goes this way, z-axis goes right at you. All right? And that's some basics of geometry, basics that will be involved in, science for measurement purposes. The most common thing to know about the three dimensions is that they will be given names like height, width, and depth, right? And depth is always the z-axis. I want you guys to know that. Don't, if a person ever tells you that depth is, going to be the x-axis or the y-axis, just know that the depth is always the z-axis, because whenever you do just 2 dimensions, whenever you draw a surface area, right, what is the surface area always? Height times width. Height times width is always going to be surface area. And the multiplication of all 3 of these is volume. So, height times width. I'm going to use a different symbol altogether to go ahead and represent multiplication here, because X is not a good one. So height times width times depth is equal to volume, whereas height times width is equal to a surface area. Although width times depth can also equal a surface area, and so can height times depth equal a surface area. It depends on if you're trying to find the surface area of which side, what one of these. So, and the better way to represent that is x times y, or y times z, or x times z. And all of these are equal to surface area. All right? And that's some basics on geometry. I'm trying to make it so you guys can see that. Basics on geometry that are also going to be very helpful in science as well. But if you multiply all 3 dimensions together, it's volume, and that's measured in meters cubed, whereas surface area is meters squared, standard. Because obviously you're multiplying 2 dimensions together here, whereas here you're multiplying 3 dimensions together, which is the difference between squaring and cubing, right? So there's some basics on science and some basics on math that are both going to be useful for, hopefully, your studies. And I look forward to seeing you guys in the next one. Peace.